Hello, my name is Ralph Joseph, and this is my video submission for Lab 8. So, what did I go to implement the leave one out algorithm? At first, we were using the item-based nearest neighbor collaborative filtering algorithm from Lab 7. So now for the leave one out. At first, we're just gonna use two loops. The first one, we're gonna go to every users, and in the second one, we're gonna go to every item that the user has rated. Then we're gonna go and grab the actual rating and also hide it and try to predict it. But before we did all that, we also recalculate the user's average without that rating in a way just so the formulas just still know about the item rating to the mean, and that'll mess up the result that we're gonna get at the end. And after that, we just set the rating to 0, we update the mean, and now our system just don't know that that rating ever existed. For the prediction part, or did we go with the prediction part? We loop through all the items that the user has rated, and we compute the adjust cosine similarity between each one and the hiding item, the one that we decided to hide at first. Then we do our calculation. We zero out the hiding rating, and that's gonna automatically get excluded from the similarity calculation. Everything that's negative or zero similarity, we kind of reject it. We sort the rest from highest to lowest, and we grab the top five, the top five one, and we're gonna consider those as our neighbors. And after that is just a weighted average. We're gonna go and multiply each neighbor's rating by the similarity that we found, add them all up, divide them by the total similarity. And in the case that we didn't get any neighbors, we're just gonna go back to the user's average. Then we're gonna clamp it between 1 and 5 so we don't get anything out of the range. After that, when we get all our prediction, we're gonna go back and we put everything back to normal. We're gonna go back and put everything back to normal so the data set is ready for our next round. And for the MAE calculation, every time that we try to predict something, we're just gonna go and take the absolute difference between the prediction and the real rating, and we're gonna save it. And after we've gone through every single rating that we have on our data set, we're gonna add up all those errors and divide them by how many there are in total. And that's our MA. Right, so now I'm gonna show that our code is running correctly. Right, so it took us around 2 seconds to do all our calculations, and our result was 0.778. That goes in line with what the professor was asking for, something around 0.77. Well, this is my submission for lab 8.